0.33, that is the size of 1 pixel. So this is a mistake what I have written here. So number of pixels in 1 mm. Suppose I say in 1 mm how many pixels. So if 1 divided by this, you will get the number of pixels. A number of cells or number of dots. It is 12 number of dots in 1 mm. So let us calculate. We wanted to know DPA, dots per inch. So that means in 1 inch, how many dots are there? In 1 inch means 2.54 centimeters. So it is 25.4 mm. So then number of pixels in 1 inch equal to, if we have 1 mm 12 numbers, 25.4 mm how many number of dots are there? You just multiply 25.4 multiplied by 12. So then you get a total number of dots. It comes around to 304.5. So it is something like a 305 dots per inch at which the map needs to be scanned. So let us go further. So when you scan also, sometimes what you can do is you can scan at 1 bit scanning. See, I wanted to only convert, only lines are there of contours. Why should I scan at a higher level? So I wanted to only know that whether there is a value or not. So if there is a value, I just say that put a 1. Basically, finally you are converting into a vector. So even 1 bit scanning, then you can save a lot of space and then time also. So if you do 1 bit scanning, it will be converting into a yes or no, true or no, true or false. So it is basically putting one value wherever the value is there. So this is before digitization, this is the process. We can do 1 bit scanning or you can do 8-bit gray mode scanning. Suppose if you have only black and white scanner, if somebody is buying a scanner, so buying a color scan is the most expensive one. So you can go for a black and white, which is cheaper. So in that case, you can scan 1 bit scanning or 8-bit. 8-bit means it becomes a 1 byte. So 1 byte is 0 to 255. So then we have a 256 levels of values. So when you scan a map, then you take a small portion of this and you put it here. So then your values will be ranging from 0 to 255. In a white area, it is coming 128, 120, 142 like this. So this is one way of scanning in 8-bit mode. What is the output of scanner? This thing, scanner output is only digital copy of the source document in a raster cell values. So that means it is there in a raster format. What you have to do, you have to data are not structured into classified and coded objects. So that is scanned, but it is scanned in a digital numbers 0 to 255. It is something like a satellite data which is coming. So that also it doesn't have any value like it belongs to vegetation, it belongs to water, etc. So then you have to convert that. So that means they have to be classified and coded this thing. To obtain this, the data have to be vectorized and further structured. So that is the requirement. So when you do automatic vectorization process, so you do it the conversion from raster to vector in 2 methods. One is you do it a skeletonizing or feature forming. Skeletonization means you scan it in a 3 raster cell width and then you eliminate the pixels surrounding that. Suppose if thick line is this thick, slowly remove the other raster cells, only center line is formed. So that is one way of thinking. Other way is you just form the feature according to the group of raster cells, you form a feature. So let us see one small example. So suppose this is my map here, that is this is a line map, and then I vectorize. So I do maybe 3 raster cell width or maybe 5 raster cell width. Here it is taking 4 cells, so 4 raster cells. Each one means 4 number of cells. This is the width. So if it is only 1, it should have been 1 line. So this much width means it has scanned in 4 raster cell width. And then when you convert this, it is converting it. It is also done a 1 bit scanning. So that's why your ones are placed here, other places 0. This is the scanned and then after scan, then then if you remove this thing automatically, what will happen is your output looks like this. So there are some values are there here and there, and then your output is coming like this. Somewhere it is bend is coming here, so then it is not joining. This is unnecessary bend which is not required. This is additional, because here cell width is more, here more 1 number pixel is created. Even sometimes you do a manual map, you try to think that this is maybe 0.25 mm width. Some places maybe it is slightly more, some places it is slightly less. So wherever it is more, it will also create a more number of cells on that. So automatically that places you have this type of problems also arise. So this is the original line work at which you scan at a certain width. So then otherwise that you see the same thing in the number of cells. You see this is the number of cells, scanned line work, how it looks, and then you basically are skeletonizing, removing all the cells, only leaving the central cells. So that way your lines are vectorized. Whatever the red color you are seeing, that is the vectorized line. This is. See, this is very important. Basically, when you talk about GIS, inputting is very important. It is also your 75–80% of the time is consumed for vectorization. If you are doing automatic method, probably it becomes faster. So this is what we are explaining is doing automatic method. So you see this red line is basically your digitized line, and then vectorized line. The blue line is the original line. So this line has been shifted here. So this is more line here. So instead of this straight line, it is coming here. So like this, vectorized line. See, when you come to the vector editing, the sky, you see there are so many things will be created. Suppose you say your line is formed here, and then it is automatically you vectorize, your line is formed here, but at the same time there is a slight bend is here. So those things have to be later on eliminated. So this is the scanned map. This may be the line, but additional these things are coming here, so that has to be, your line is properly not joining, there is a gap in between, so that has to be removed and created. And this is the, instead of a straight line joining, there is a slight bend is coming, that has to be removed. There is a cloud of points which have been created. Probably there is some patch on a map which also created, digitize the lines, so that those things has to be removed. So this is the line earlier already